Hello guys, good morning everyone. Welcome to another episode of Xah Talk Show. We are going to code Wolfram language today, Wolfram language geometry. So we're gonna spend an hour to create Wolfram language code like that to draw this thing. So it will be a general function. Anyone can just copy it and paste the code and it'll run. So the goal, I already have the code here, but the goal is to not use a package. Like this is my code, but it requires this package you have to download for free. It's on my website. I talked about many times. But we're gonna rewrite this so that people don't need to have this package installed. You can just run the code. About 60 lines of code. Okay. In fact, we can shrink it. We can make it like just a few lines. So anyway, that's a goal. So the goal is to create a program that allows you to draw the actually not we already have this code. Actually, it allows you to draw any caustics. Okay, so it's more complex. This is just tangents. I mean, this is just normal lines. Okay, normals are lines that is perpendicular to the tangent. Okay, so but we are going to draw a code that does this. Okay, that does this reflection. So optical properties. So you have a ray, light from a light source, light ray from a source, and it bounce off the curve. It reflection or refraction. Okay, that is what we're gonna code. Now this one is normal lines. We already coded. Let me show you. Okay, let me show you. So anyway, if you are watching this offline, play at 1.5 speed. If you are here, say hi. If you are offline, fly. If you are here, say hi. Okay. So we're gonna code this. It's gonna be like an hour talk. Yeah. Okay. So is everything good? So if you don't know, I've done by now over 100 videos on Wolfram language. You can download the Wolfram language. Just search for Xah Ep Wolfram language for programmers at xahep.com. Okay. So let me demonstrate one more time. Copy that. Wolfram language. Wait, what did we copy? Okay, not that. So we want to copy that. Wolfram language for programmers. Okay, that is a Wolfram language site. Do they show my website? No. Okay, so yeah, so that's all Wolfram language website. They have very good documentation, but they literally have like millions of pages. So there you can see launching today free Wolfram engine. So that became free in 2019. So Wolfram language for programmers. So fast introduction. That's their introduction, but they have different approach. Mine, well, of course, I believe mine is better. So there it is, Wolfram language tutorial. Okay, so you can download it and so on. But on xahep.info. So anyway, so let's go back to what we want to do. We want to code this. Okay, so let's do that. Okay, so let me show you first of all this normal lines. Okay, so first of all you copy. So let me show you. So this code will create any copy, paste, shift, enter. It lets you draw the tangents lines and normal lines for any parametric curve. Okay, so this code is good. Okay, so then okay, so we got that copied. So what are we doing? So here's a code. Okay, that's so we want to go to the hello Machis Melchis Zedek. Greeting from Germany. Hello Germany. So now for okay, let's go there. So we want to regenerate this image. Okay, so let's go this. We want to open Alphabet. So what section is this? Evolute. Okay, search for Evolute. Okay, and then there is the Wolfram language code that we're gonna create another one and pop it out. And okay, so hold on a second. Yeah, here, paste it, pop it out, and we need to know what is the equation, the parametric equation for this S-shaped curve. Okay, so let's copy that. So the parametric equation is just that. Okay, okay, so that would be cosine, sine, sine, cosine, sine, cosine. Okay, so that would be, yeah, so you just copy that and replace this part. So that is the curve function. Okay, and the other important thing is the plot range. So it's t from 0 to 2 pi, and in steps of 2 pi over 60. That's the steps. That's also important. So let's put that somewhere. Plot range, yeah, so plot range here. Now you don't 0 to 2 pi, okay, so but you don't take a step over there. Cut. Okay, 0 to 2 pi, and in steps of in steps of 60. Okay, so what you do here is, so that is the range, so you just say range is like this. Range function is like Python's range. It generates a list of numbers. So you just say 0 to 2 pi and in steps of 2 pi over 60. Am I good? Video check, audio check. Hello Germany. So this creates, let me show you. So we can run it. It will create a bunch of numbers. Okay, incorrect. Oh, you don't want the brackets. Okay, so do it again. You see, now now that's symbolic. You know, Wolfram language returns symbolic result. So that's interesting. For example, you run this in Wolfram language, it's symbolic result. Now, if you want numerical, all you have to do is you slash, that's postscript notation. N is the function, that means numerical. Or alternatively, just any of the number, you give it a machine number like 60, then it returns machine precision. Okay, so that is the range. Okay, so delete that, cut that. So the range list will be that. Okay, and let's say N, capital N, is the numerical. We want numerical results, so it's much faster. So what else? So plane curve plot. So curve color function, we don't care. Dot plot curve, aspect ratio, and plot range is important. So plot range, because it's specific to each curve. Okay, plot range that. Okay, so let's see what else. That plot curve, that special plot range, aspect ratio, axis true. Yeah, usually we want axis so we can see. You see, like when you do mathematics, usually you want to draw axis so that you can see what things are where, especially when you are coding it. Now, if you want artistic representation, then if at the end you remove the axis, so you got kind of more of artistic representation. Okay, So anyway, so that you don't need anymore. No need for that package. So this is all code. So I think that will work. Let's try. So select all, paste. Okay, there's a code. Shift Control N to make it typeset. Fantastic and beautiful. Now we got arrow here. We got an extra comma, so it became null. So we don't want that. Okay, so so that means I got that error in my other code. So let's go fix it. So open tangent. Okay, so yeah, there you see that you don't want the comma. So copy that, select all, paste, Shift Control N to typeset. Okay, there's nothing special. Okay, Shift Enter. That's tangent lines, the red, and the normal lines, which is perpendicular to the tangent. Okay, so so we fix that, put it back, syntax correct, show in browser. So that it's about tangent page. This is also on my website, by the way, so you can copy the code. But again, I got an issue with my website, so it hasn't been. I was not able to update it for a month. So, but it should be fixed. So by the time you watch this video, I don't know, in the next week or so, it'll be fixed. Okay. So anyway, we fixed that tangent code. Okay, now close that tangent. Now this, go back to this. We fix that. Okay, copy that. Now go back here, select all, paste, Shift Enter. Let's see what we get. Fantastic, but we don't get the tangent and no more lines. Okay, we plotted the curve, and we also got the dots. The dots should be but where are our lines? So we got some issues. What does this language do better than Python? Oh, it's a magnitude better. It's like a magnitude. Like, okay, let me explain in 5 minutes. Let me explain in 2 minutes, because I've done hours and hours of video about why Wolfram language is a magnitude better. You can just search for my YouTube. Well, maybe I should show you one, but anyway, so the reason is that basically one line of Wolfram language is equals to 10 lines of Python, or 1,000 or 1,000,000, depending on how you count. Now, if you go by just Python itself without all the the math libraries or NumPy and all that, then one line of Wolfram language is like 10,000 lines of Python, because normally if you just code without mathematics, one line of Wolfram language is like 10 lines of Python typically. Okay, but if you count mathematics, like solving equations, doing integrals, derivatives, matrix equations, differential equations, then obviously Python cannot do that. So you need NumPy and all that. Altogether, you got like 4 gigabyte, few gigabyte Python libraries, altogether, including machine learning. You can, like there's Anaconda, you can pack it together. I believe that's what called like Python huge thing. Download Anaconda distribution. So that's like 3 gigabyte or something. That combines everything in Python, or math, sciences, engineering. So, and also machine learning. Like it basically packs everything Python together. Okay. So now, if you compare this with Wolfram language, it's still true. One line of Wolfram language is 10 to 100 lines of Python with the Anaconda. That's what I mean. That's why it's a magnitude beyond. And you don't have to load any library. Like by default, you got 7,000 functions built in. Like in Python, when you want to do regular expression, you need to load regular expression library. When you want to go through files in a directory, you need to load, system.io or file path library, traverse library, and so on. But in Wolfram language, it's all built in by default, 7,000 functions. Then, of course, then you got libraries, you got lots of other things and cloud stuff, and but anyway, so that's kind of the summary. Okay, so why this is far better, far a magnitude beyond Python. Now, so why didn't people use that? Well, because there are several reasons. Because first of all, it's not open source, so you have to pay. Now you can download for free versions, of course, since like 6 years ago, free, for personal use. So it's fantastic. And also, of course, all this quality, you see these images, if you do this Python, it's going to be ugly, okay? Well, a lot ugly. And you have to trick, you can't do this or that, it's like cumbersome. In Wolfram language, it's all like well documented and powerful because it's commercial product, okay? So anyway, so it's free, and so also the other reason is Wolfram language is typically slower, okay, because there's lots of symbolic. It's like a symbolic system. So it's but they have parallel computation and stuff. Anyway, so that's my kind of summary, okay, about comparing to Python. I did a video like before, comparison to the what is that package. Okay, hold on a second. Let me does that make sense? Dash Hua Nuo. Does that make sense? So if you can look back, let me show you. So so this is Xah Talk Show index page. So what is that? Last month or 2 months ago, because I have done so many videos, by now 700. So the Python is actually one of the worst language. Just search my YouTube. I've done quite a few. And why Python sucks? Python is really the worst language from design point of view. And what is the one I wanted to talk about? The what is the package? That open source math package. Are you still here? Do I make sense? Dash Hua Nuo. So let's go to my Twitter, because there is this thing I wanted to mention. Okay, we are digressing. We need to get back to code. Okay, so let me just quickly wrap up. I wanted to answer that question that these open source people so we want to focus on mathematics, not politics. Donald Knuth, there's a news. Donald Knuth used AI to solved one of his problems, Claude's cycles. Fascinating. Oh, shit, I just wanted to show, God, not other stuff. I wanted to show that yeah, this, okay, so this you see, these people, when I, these people, it's talk sage math, okay, God, Jesus, sage math. So that's episode 731. So when was episode 731? That's 2025 December, okay. So that over there I talked about Wolfram language versus sage math. Sage math sucks very bad. Okay, so anyway, so anyway, okay. So if I answered your question, say, tell me what you think, okay? Dash. Okay, so let's go back to code. I want, let's go back to code. So yeah, so we were doing this code copy, so we got a bug. Yeah. So why is the curve not showing? So God, this font is really too large. I got some itch, some allergy or something on my arm here. So it should draw normal lines. Okay, so why is it not doing that? Because what is this? Okay. Okay, so that's my, okay, let's see the code. So why is it 9 drawing lines, tangent lines? So okay, the font is really too large. Can't work with this, so we need to shrink it. Because when you are doing a video, to me it looks huge, but to you it looks small. If I use a normal sized font when I work with computers, then it's like gonna be tiny for you guys. So, on my screen, these fonts are like humongous. Anyway, so why do I have this problem? So the curve function, okay, let's look at one by one. Okay, focus. So that's a function for the curve. And what is this? This is a tangent vector function, which is a derivative, okay? So actually, better just name it direct derivative, curve derivative, okay? So, and this is a range list, okay? So list of ranges, that makes sense, yes. And this is tangent length, tangent line length, okay? And normal line length, okay? Then over here, you plot the curve. So that's how you plot the curve, parametric plot. And then over here, this block is about creating graphics. So you are like creating graphics for tangent lines and normal lines and points on the curve. Okay, so then you got points. Okay, so points equals to the curve evaluated at t. So what we got here is a table. So you can see this graphics thing has the first argument is this table. Okay, so this table generates a bunch of lines and points. Okay, that's what that does. Now the second argument to the graphics is just axis. These options: x is true, plot range is that, and aspect ratio automatic. Okay, that automatic means make it, you know, not shrinked, or, you know, so that the length of one unit on the x-axis and y-axis are equal. Okay, that's what aspect ratio means, automatic means. Okay, so then the heart of the code is about this table. It generates a list of things, list of basically the lines and points. Okay, so but then it declares a local variable, several local variables. Points, okay, point is that then unit tangent vector, okay, normalize tangent vector at t. Tangent vector at t, that's a derivative function applied at t, gives you a point. The point, a list of two numbers that represents the tangent vector. Then you normalize it, make it a unit tangent vector. Okay, so that's what that is. It's a point. Then x tangent vector equals to unit tangent vector times tangent line length. So you make the vector to have the length of the tangent line length by the specification, by the user spec. Okay, and then you make the normal vector to be yeah, so that, okay, so that so why is it not working? I don't understand. So so let me just make this TGT and let me run it, and let's see what's going on. Okay, so but let's reduce this to just you know, 5 points. So it will return. So here is where, you know, we can see the actual thing, what's going on. Because when you have this graphics thing, when you say, you know, when you say graphics there, you know, for example, that graphics, then it just shows the graphics. It doesn't show the actual expression. So when you replace that graphics by just some random symbols, symbolic, then you can see this is what you get. So you can see here, why is it not, so this draws a line from 2 to 2. So what's going on? So you got a line, you got a point, you got a line. So lines, you see, these are lines beginning and end at the same point. So that's why it's not showing. Okay, so why is the lines beginning and end at the same point? I don't know, but that's, well, that's because God, I don't like its block is a problem. I think there's quite a bit of latency in the stream, so he might take a while to respond. Okay. Okay, Ashley, don't spam. Okay. So this unshared, we got a problem here. Why is it not what? God, this it's hard to debug. So if you define a function like that, and here is the derivative. Okay, so the derivative is incorrect. Okay, so I know why. Oh, obviously, because we made a mistake. You see, this expression is a function, right? But it's an expression involving t. now can you guys see? You see this let me shift control N. So you see this expression involves t, but we say it's a function where x is the input, so that is wrong. That should be t. So obviously we made a idiotic error when we replace the expression. So this should be t. God. So copy all, go back to Wolfram language. So select all, paste, Shift Control N to make it typeset, and Shift Enter to run it. Okay, we got well. This TDT, let's return TDT to graphics. Okay, copy all. Yeah, so this looks much better. Yeah, select all, paste, Shift Enter. Okay, now still no. Wait, did we change what? We got another problem. Okay, I don't know what's going on. So let's Shift Enter. Could not combine the graphics. Okay, so again, we got this problem, but the function is now it should work, right? Well, maybe because of the yeah, cache kind of issue. Is that right? Because if you say such that, you see you got that, so maybe it's could the cache problem be? So if you run that first, paste, okay, then Shift Control D to separate them, Control Shift N, Shift Enter, evaluate that, Shift Enter, evaluate that. Okay, so this is the derivative of that function. Okay, does that make sense? Yes. Now let's try to evaluate this part and let's see if it works. It does, you see, because of okay, yeah. So what you get is a kind of cache problem. Now that's another bug because when you use block, you shouldn't have a cache problem. So I got an issue I need to resolve. Very annoying. This anyway, let's change this to 60. Okay, so and Shift Enter. So now you can see. Now you start to see pretty pictures. Now let's make the normal line length to be long 50. Shift Enter. Fantastic. Now it doesn't look pretty when you have both normal lines and tangent lines. So let's not draw the tangent lines. So all you have to do is just remove the tangent lines. Okay, remove it. Shift Enter. Fantastic. You see, so now we got a code, which is what we wanted to do. We wanted to show this nephroid. By the way, this curve is generated by rolling a circle outside of the circle. The rolling circle is 1/2 the size of the fixed circle. Okay, so this curve is called nephroid. And we wanted to do this one. So this is pretty using my package. And without my package, here's a code, about 10 lines, okay? you know, so now it's looking pretty bad. So because all the color, so let me fix it, put it back. Okay, now this is the code. Okay, 20 lines of code. Okay, to draw that. Now we want to, now this is, you know, so, you know, we need to make it pretty. For example, this make it red. And well, I mean, the dots, we want it red. Okay, so actually the curve make it black. Okay. Okay, so we want it black, and this red doesn't, let's make it blue. Okay, now it's looking better. Now, okay, this looks better. I like that better. So instead of blue, you use a hue 0.75 by experience. That's about, okay, that's purplish, or 0.7. Okay, what color did I use? Okay, it doesn't say what is the default color. Anyway, so that's one of them. Okay, so we coded that. Originally what we wanted to code was this reflection. So you got the light source that shines rays on a curve and reflect it off the curve. So, but we already spent like 40 minutes. So I think today let's just be this. Coding takes a long time. Okay, so here's a code. Now let's do some final touch up. Okay. Also, we got an issue because this code is supposed to be robust. That means doesn't matter, even if you have a local variable that's named fcurve, it shouldn't affect the code, so that user can paste the code anywhere it should run. But however, it turns out we got this local variable bug, because if you change this fcurve to something, let's say TTT, okay, let's say even, let's just say 3, okay, if you run it, then, okay, delete that, delete this, okay, so you see, you set that to that, and now you run this, it will no longer work, okay. Now this is not expected. So why does that happen? Because do you guys see what I'm saying? Okay, so why is this? So let's go back here. Okay, so this contaminated get okay, I think maybe it's because that. Let's try again. Okay, let's just try this t sign at tt. Okay, so copy all, go here and select all, paste, shift enter. Okay, so this is incorrect because, yeah, so apparently this definition affected the code. So why is that? Okay, so you don't even what? Nasty, kind of nasty, this kind of scope problem in Wolfram language. The variable scope issue is kind of problematic in Wolfram language. I mean, it's somewhat complicated because it's a symbolic language. Okay, so let me think. So this we are using block. Okay, block is a dynamic scope. Okay, so block means any variable in the expression in the block body, it will replace any occurrence of that by the function, by the definition you gave there. And this is dynamic, meaning that not just what you see, like what you see there, but also whenever any expression that runs that comes up with this f curve variable name, it will become this new value. Okay. So why? So okay. So I think I know what's going on. This is annoying. Okay, let's see. For example, let's try this again. Okay, select all, paste, shift, enter. This is incorrect. Okay, but now let's fix it. Now we copy that. Okay, and we do it here. Okay, and in this line we comment it out. Instead, we just say variable. Okay, so instead of declaring a variable and give it a value, by the way, this f curve prime, that means the derivative of this function. It creates a derivative. Okay, so I mean, to your early question, can you do derivative in Python? Well, in Wolfram language, this line does it. Okay, so this is a function, this is a derivative, and this is derivative does to not just a single function, but it's a parametric equation. Like it does derivative to both of these functions in one shot. Okay, that's illustrates the why Wolfram language is a magnitude higher level. So one line of Wolfram language is like 10 lines of Python. Okay, that's like one example. I mean, in Python, you can't even do derivatives unless you load, the bunch of math libraries. And also, I'm not even sure, even with, this Anaconda or the, math libraries, Python actually do symbolic derivatives and integrals? I don't think so. Actually, that's an interesting question. So I don't think so, but let's ask, can Python with its math libraries do symbolic derivatives, symbolic differentiation? Let's just say derivatives. Yes, Python absolutely can do symbolic derivatives, and the main and by far the best way to do it is sympy. Okay, sympy is a full-featured symbolic. Okay, it can do derivatives, but can it do differentiation? Possibly, it can do. I'm sure it can. There's a package. Since you got the symbolic derivatives, it's likely you also have symbolic integration. in Python, in some, maybe SymPy, probably in SymPy, okay? But I can tell for sure then it's gonna be inferior than Wolfram language. Because this gets very complicated. Anyway, so let's go back to this. Okay, so we declared, so instead of declaring the variable and give it a value, we just simply declare the variable and we give the value here. So copy all, so select all, paste, shift enter. Now it works, you see. So the problem, so now I discovered the problem. The problem is that you don't want, when you want to use block, it's best not to not also declare the value there. The reason is because if you do that, you see, if you do it here, it is going to use the global variables value there. You see, in over there, see. Why? Yes. Yeah. So, it doesn't, in other words, it doesn't do chain variable chaining. So that is why. So, okay. Very nasty. Okay. Anyway, I think we finished our code. We found the problem, and I think that's it. How do you pronounce your name? Like Melchizedek. There are several ways to parse it. Melchizedek or Melchizedek. By the way, have you ever used Maxima? Okay, how does it compare to Wolfram language? There's no comparison. I mean, I got these kind of questions all the time, like since several years ago. Well, people ask that because if you search my YouTube, you might find it, okay? Like Xah Ep YouTube. Okay, you need to go to YouTube. Let's go to YouTube. Like search for Xah Ep Wolfram language versus Maxima or Wolfram language with Python. I talked about this so often. People wanted to ask that because I have like 30 years experience with that. They wanted to ask that because Maxima was, it was a commercial product, but now it's open source. So the open source people are very excited. Have you ever used Mathematica? Maxima. How does it compare? Also, Maxima is written in Lisp. So you got these open source phonetisms all the time. But the thing is, okay, let me just be brief because I'm starting to become like 1 hour rant. The thing is, have you ever tried, just spend 1 hour to be practical, not 10 minutes, because in 10 minutes you can't even download a thing, right? So you spend few hours, try it, spend, let's say 5 hours, just 5 hours in your life, run Wolfram language, and 5 hours in your life, download Python, the whole Python symbolic library, everything, or Maxima, like just try it for 10 minutes. You'll know right away. Like spend 1 hour, you'll know right away which one is better. Okay, and in fact, I can tell you, all the Python or Maxima, they are gonna be 10 times worse if you actually try it. But I got, this question. I don't mean to blame you or anyone, but I do get this question like so often. People will start asking me, have you tried Maxima? Have you tried Sage Math? How does it compare? Have you tried GNU Octave? Have you tried GNU Plot? Because the open source, it's free. People wanted to know, well, yeah, you are showing Mathematica, it looks great, but I know this open source. What do you think? Have you, there's no comparison. But once if I tell them there's no comparison, one is like toys, like literally, like I would say today, because if Maxima or this Python, if they are great, Wolfram language has no business. you know, that like it's proprietary. They sell like if you are a Google or the NASA, you know, Google, these corporations, they use Wolfram language. Even Donald Knuth, you know, have you seen my Twitter post? You know, like go to Donald Knuth homepage. He uses Wolfram language. He also uses Emacs. Okay, and Donald Knuth like last month was surprised by AI because AI solved one of his problem. Anyway, like so if all these people, you know, all these packages are so well, you know, like open source stuff, then nobody is using gonna pay, right? Hello, Hank. Ching ching, thank you, Hank. Have you tried GNU Emacs? That's right. Yeah. Anyway, so I think we solved this. We did this fantastic, and that's it for today. So but you know, so yeah, so I need to actually okay, let me complete, just to be totally complete, let me make this code fully robust. Okay, so we don't have this bug, fix this bug for good. Okay, so the way you solve it, just okay, just do this. Okay, so copy all that. Okay, and go here, paste all that, and replace the comma by semicolon. Do that actually just at the end. Okay, just at the end. Okay, semicolon. Okay, and over here, this block of variables, let them just be names. Okay, so you don't want anything, just names. Okay, you don't want any value, just names. Okay, names. Okay, names. Okay, so now it's like, you know, kind of easier to read even. So you got this. These are local variables. Dynamic scoping, that's what block means in Wolfram language. Okay, then you define their values. Okay, so that's a function. That's wait, function come first, and here is a derivative. Okay, then here's a list of ranges to the list of points like you want to evaluate. Then you want to say tangent length and normal line length, let's say also 60. Okay, then then you show, then you plot the curve too. Okay, that should be robust code. And also here, so you can see block is used again, but this time I don't have, you know, the values there. So copy all. Let's go to Wolfram language again, select all, paste, Control Shift N to typeset it. You see, you also don't have this very nice automatic formatting typeset. Look at that. In Python or in you know, in LaTeX, you know, you just press a button, it does that. And you can have traditional style, Control Shift T. So now you are more from, you know, it's formatted more like traditional mathematics, which is problematic because the traditional way of typesetting mathematics, they are ambiguous. So one example is the absolute value or the norm of a vector. We are computing normal, normal vector. So you got two bars, but you don't know which part is nesting where. Anyway, this traditional math notation. Okay, so Control Shift N to go back to the Wolfram language standard notation. Okay, then you Shift Enter to evaluate. Fantastic and beautiful. Now this is like the psychology thing. So we don't want to plot a tangent. But anyway, that's it for today. Thank you, Hank, and Ching, and bye, guys. Okay, we coded exactly 1 hour. Okay, so we actually, so we can improve this. So let me do more. Okay, so in this case, we have a general code to plot. That's right. We got a general code to plot normals. Okay, so in this case, put it back first, syntax color it, show it, and go to the normals. So go down. So we're gonna delete that. We want to make this our code pretty like that. Okay, that's the job. So so what is this? Okay, so we're gonna delete that soon. Now this is our new code. Paste it there and put a line. Refresh. So this is today's code. This is the code from the package from there. Okay, now we need to go back to the tangent page because we have something to fix. Okay, so showing browser. So that's tangent. Now remember, we don't want values inside the block local variable. So let's fix that too. So we actually because well, you can have them inside, but you don't want them to be chained like this. For example, this you see this the value of this local variable depends on the previous local variable. You don't want that to happen. Okay, so let's because when you have this situation, then you get into the variable value collision problem. It's gonna be a bug when you have a global variable named like that was used in the chain, for example, here. So when Wolfram language sees this F curve, it will first check the global variable. So that's a problem. So this is it's I would say it's a design issue. So anyway, so the way to fix that is again we paste everything here. Use okay, then here just don't give it any value. Okay, okay, so that okay, so that copy all, select all, paste, shift enter. Fantastic. Okay, that's tangent. Put it back, syntax color it, go to the next one. This one also need to fix 1 2 3 4 5. Okay, back here. Okay, then here you just don't want that, don't want that. Okay, that double check, no comma at the end because Wolfram language doesn't like trailing commas. Okay, so you got that. Is everything good? So block, yes, copy that. So select or paste, shift enter. So this is generic code for drawing any tangent and normals. Okay, you don't need any packages. Fantastic. Okay, now put it back, syntax color it, showing browser. So there's a code. So in the future, by next week, you can search for my website, special plane curves, a visual dictionary of special plane curves. Then you can, the code will be updated. Not now because I got some issues with my web server. Okay, so this is tangent and normals. Okay, draw tangent, arbitrary tangent and normals. Okay, now that's fixed. Syntax color the page we did. Okay, so now there's no leak of variables, local variables. Wait, that's right. Sounds good. Okay, close. Now this nephroid. Okay, so now we just want to make it pretty, right? So select all, paste, shift enter. Yeah, we want to make it pretty. So we want to make it like kind of like this. It's so pretty like this. Okay, so Okay, so the curve is black. Let's go one by one. The curve is black. Okay, class style black. Okay, and you want the dots on the curve to be red, so it looks like rivets. So you want the dots to be red. Okay, so that you want the points to be red. So there, points on the curve are red. Okay, so yeah, so red, and the tangent lines. Now, right now you do tangent lines. Do you want tangent lines? No, because it would be confusing. So the tangent lines, you don't want the tangent lines. This you don't want. Okay, let's highlight it. Tangent vector. Okay, so you don't want this line. No, don't draw tangent. So, but we still need this. Actually, no. So since you are not drawing tangent, you don't need that. Okay. So you can like comment out. Okay, so select all. Okay, select all. Go back here, select all, paste, shift enter. Fantastic and beautiful. Now, do we want to change the color? You see, so actually this is pretty good. Now select it. This is some kind of cyan color. So can we say cyan? Is there a cyan defined? I'm pretty sure. Yep. No, I don't like cyan. Light blue. So is there light blue? Light blue. There is. Okay, no, I don't like light blue. So what is the color I was using for my over there? I don't remember, but so let's increase the dot size. Font size 0.02. I think that's huge. See, so 0.05. That's too small. So 7. Okay, so 1. Shift enter. Okay, so size 2. Shift enter. Wow, wait. 2 and 1 differ so much. So about 1.5. Okay. So this kind of looks good, but I like that color. So what is that color? Now is that due to like interesting. You see, they automatically have transparency. You see, so these are kind of features you don't get in Python. You don't get in Python. I mean, you don't have this interactivity. You don't have this typesetting. That's what I mean. Okay. So shift enter. So, and is it, so let me copy this, do a screenshot. Let's do a screenshot. Okay. Just say, okay, we got a screenshot, and let's see. So put the code back, and let's do showing browser. Okay, so we got that, that's not what we want. That's my previous screenshot. Open it, delete it. Okay, this is what we want, but the color Now you see, fantastic. Now let's put them close together and delete the code here. Okay, so search for pre. Wait, so so search for pre again. So this is my code for my package. You see, it's much shorter, but then you need to download this package on GitHub. So don't want that. Delete. Okay. Now this is the image. Now cut it and move it up here so we can like compare side by side. Okay. Showing browser. So you can see now side by side they are huge. Okay. So so I do like this color better. So let's find out what that color. I'm pretty sure it's hue 0.5. I'm pretty sure it's 0.75. 1.7 something. Okay, so let's look at my package. So go to Xah Git directory, go to curve, search for curve plot, and this is the file. Search for caustics. Search for normal. So there it is, hue 0.6. Oh God, how could I forgot? So hue model 0.6. Let's see. Oh, I like this better. So fantastic. Finally, okay. So let's so this is our final image. Copy that. Oh wait, shit. Shift enter. Yeah. So now screenshot. Okay, and close that. Fantastic. And do it. Okay, and you will name this. This will be named nephroid normals. Okay, so rename the image nephroid normals. Okay, and there's one more to rename. That's the previous. Okay, and go back to the curve, refresh, so you can see our original, the current, fantastic, and the previous. Okay, now just delete the original. No, wait, delete that, and this you don't need neither. Delete it. Go back, refresh, fantastic. So this is the evolute. By the way, if you don't know what is evolute, I'm not gonna explain. Okay, so watch my video 2 days ago. I think I explained that. Evolute is fascinating, but you can understand it by visually by watching this movie. Okay, just look at this movie, stare at it for a while. Those red lines is the evolute of this ellipse blue curve. Okay, and you can read on Wikipedia. Just search for evolute, and you'll find it. Okay. So anyway, that's today's fruit. We drew the normals of this nephroid curve, and the normal forms a shape that's called the envelope. So the envelope of the normals of nephroid is another nephroid. Okay, that is the conclusion. Bye, guys. Thank you for watching. Bernardo Loops, thank you. Hi. Hi. If you like, so general advertisement, if you guys like my work, donate, okay? Pay me, go to xali.info. Xali.info. You can, xali.info. Then go to the bottom. You can find my Patreon, Amazon gift card, PayPal. Donate, okay? Because that makes things go. Okay, and tell friends about my video, post it. Yeah. Bye. Bye, Melchi. Bye. Fantastic. Fantastic and beautiful. Bye.